So section 10.6 is solving right triangles. I will talk about what that means a little bit into the lesson. So first we're just going to review the Pythagorean theorem because we're going to use that to solve right triangles. Remember Pythagorean theorem is hypotenuse squared equals leg squared plus leg squared. So x squared equals 4 plus 36. So that means x squared equals 40. We're going to take the square root of both sides to undo that squared. And we get x equals the square root of 40. Well, square root of 40 can be simplified. So let me do a prime factorization tree. Let's break these down. Okay. I'm going to cross out the 10 and the 4 because we broke those down even further. So now you're going to look for couples. Remember, couples go out. They go out to one restaurant. And then singles have to stay in. And there's two singles, so we're going to multiply those together to get 10. So we get x equals 2 square root of 10, and that's our hypotenuse. So that's just a reminder of how to do the Pythagorean theorem. Now, up until this point, we have used trig ratios to find missing side lengths. We can also use trig ratios, inverse trig ratios, to find angle measures. So for example, we know the tangent of an angle measure A equals opposite over adjacent. Now, just like we do with addition and subtraction, multiplication and division, squared and square root, those are all inverse operations. So I am going to take the tangent inverse of tangent of A, and those are going to cancel each other out, and we're left with just the measure of angle A on the left side. Now, if we do something to one side of an equation, we have to do something to the other to keep my equation balanced. So the measure of angle A equals the inverse tangent of opposite over adjacent. So that's what we have here. So if I want to find the measure of angle A, which here is denoted by theta, that green symbol, we would do measure of angle A equals inverse tangent of this opposite side over this adjacent side. And then we would plug that into our calculator, and I'll show you how to do that on this next example. So use your calculator to approximate the measure of angle A to the nearest degree. So if I'm trying to find the measure of angle A, let's look at the two sides we're given. We're given opposite and we're given the adjacent side, which means I'm going to use my inverse trig function to find the measure of angle A. So anytime you're finding the measure of an angle, we're going to use the inverse trig function. So opposite over adjacent is 8 over 10. And then we're going to plug that in our calculator. So I'll show you how to do that. So we want the inverse of tangent. So we're going to hit second, and then you can see in blue above the tangent button is inverse tangent. So that's what we want. And then we want to type in 8 divided by 10, and that equals 38.65. And I think they asked us to the nearest degree. Oops, wrong one. There we go. So that is, yep, to the nearest degree. So the measure of angle A is 38 degrees. So let's do another one. So if we're trying to find the measure of angle A, look, you first have to decide what type of sides are you given. Well, if I'm looking at angle A, 5 is the opposite side, and 9 is the adjacent side. So that means to find the measure of angle A, I'm going to use the inverse tangent because tangent is opposite over adjacent. So now we're going to type that in our calculator. Inverse tangent of 5 over 9. So here's the inverse tangent. So second tangent gives us that inverse. 5 divided by 9 is 29.05, so the nearest degree is 29 degrees. So use your calculator to approximate the measure of angle A to the nearest degree. Same thing. Yes, these have all been tangent. We will get to using the inverse sine and inverse cosine in a minute. So the measure of angle A equals the inverse tangent of opposite over adjacent. Again, you're going to plug that in your calculator. So we want the inverse tangent of 17/20. And that is 40.36. And they wanted the nearest degrees, so that would be 40 degrees. So same thing here. This is the opposite side of angle A. This is the adjacent side. So we are going to use the inverse tangent to find the measure of angle A. So that's opposite over adjacent. And when we plug that into our calculator, we get to the nearest degree, we get 58 degrees. All right, so now we look at, we can use the inverse sine function, which is going to be if we have the opposite and the hypotenuse. And then same thing for cosine, it's going to be if we have the adjacent side and the hypotenuse. We'll use the inverse cosine to find the measure of angle A. So use your calculator to find each angle measure approximated to the nearest degree. All right, tangent of A. Well, we want to get just the measure of angle A, so we want to undo this tangent by taking the inverse, and those are going to undo each other. If I do it to one side, I have to do it to the other. So in your calculator, you're going to plug in the inverse tangent of 3.5, and we're going to get 74 degrees for the nearest degree. Same thing, if we want to get just the measure of angle A on the left side, then we're going to take the inverse sine of 0.55, and when we plug that in our calculator and round to the nearest degree, we get 33 degrees. And last but not least, let's take the inverse cosine of each side to get the measure of angle A. So inverse cosine of 0.48, if we plug that in our calculator and round it to the nearest degree, we get 61 degrees. So what does it mean to solve a right triangle? To solve a right triangle means to find all three side lengths and all three interior angle measures. So you're finding all the side lengths and all the angle measures. So you're finding everything. And that's what it means to solve a right triangle. So I'm going to do 2 examples, and then you guys are going to try 2. So things to know. Pythagorean theorem, hypotenuse squared equals leg squared plus leg squared. That's what we're going to use to find our missing side length. SOHCAHTOA, so we're going to use our trig functions to find missing angle measures. Actually, we're going to use the inverse trig functions, which is what we use to find missing angle measures. So, here we have a triangle. I say always find your missing side length first. So let's find our hypotenuse C. So using the Pythagorean theorem, hypotenuse squared equals leg squared plus leg squared. So C squared equals 4 plus 9, which is 13. Square root both sides to get C by itself, and C is the square root of 13. So that's our hypotenuse length. Now that we have all three side lengths, let's move on to the angles. We know one of our angle measures is 90 degrees, so let's find the other two. So let's look at angle A. Okay, I'm not going to go off of C because we found C, and what if it was wrong? I'm going to use the 2 numbers that they gave me, and based on angle A, this is the opposite side, and 2 is the adjacent side. And then we know that across from the 90-degree angle is our hypotenuse. But they gave me opposite and adjacent, and I know those are right because they gave them to me. So if I look at SOHCAHTOA, opposite and adjacent means I'm going to use my inverse trig function to find the measure of angle A. So measure of angle A equals tangent inverse of opposite over adjacent. And you're going to plug that into your calculator, and when you do, you're going to get 56.3 degrees. Now there's 2 different ways to get the last angle measure. Okay? Personally, what I would do, I'm going to erase this, and we're going to set up a trig function for angle B. So if I'm now looking at angle B, 2 is my opposite side, and 3 is my adjacent side. So again, I'm going to use my inverse trig function because we have opposite and adjacent. So inverse tangent of my opposite side over my adjacent side, if I plug that in my calculator, I'm going to get 33.7 degrees. Now, since these are right triangles, A and B have to be two acute angles. Now I want to show you something. If you add together the 90-degree angle that they gave you, plus the 56.3 degree angle, which is A, and then the measure of angle B, which is 33.7 degrees, those should add up to 180 degrees. So let's say you didn't want to set up this inverse trig ratio to find the measure of angle B. Instead, what you could have done is we could have just called the angle B, we could just call this plus the measure of angle B, and then you could have solved this equation to get the measure of angle B. So you would have had 146.3 plus the measure of angle B equals 180 degrees. Subtract 146.3 from both sides, and you would get measure of angle B equals 33.7 degrees. So I don't care which way you do it. If you want to do 180 minus the two angles that you know, that's fine. But my only hesitation is, what if you get this angle wrong? Then this one is definitely going to be wrong. But if you set up two separate trig ratios, you can still get this one right, even if this one's wrong. So it's up to you which one you want to do. All right, so again, let's find our missing side length first. So in this case, 25 is our hypotenuse, because that's across from the 90-degree angle. So 25 squared equals leg squared plus leg squared. So 25 squared is 625. If you're not sure, you can type that in your calculator. And 16 squared is 256. So I'm going to subtract that from both sides. That's a 6. And we get 369 equals g squared. So to get g by itself, we're going to square root both sides. And this does simplify to 3 squared of 41. But since it's such a big number, I'll let you guys just write your answer as a decimal. So our third side length, the hypotenuse, is, oh, sorry, not our hypotenuse. The leg is 19.2. So now let's find our other two missing angle measures. Let's look at G first. So I'm going to use the two sides that they gave me, because what if I got G wrong? Then I don't really want to deal with that. So let's look at, they gave me the hypotenuse, and this is the adjacent side, because this is opposite since it's across from. So since they gave me hypotenuse and adjacent, let's look at SOHCAHTOA. Let's figure out which trig function that is. All right, opposite and adjacent, nope. Opposite and adjacent is tangent. Sorry, wow, that is not what they gave us. Sorry. Okay, they gave me opposite and hypotenuse. Woo! So I was right the first time. Opposite and hypotenuse. So to find the measure of angle G, we're going to use the inverse sign of opposite. Wow, guys, this is not my day. Let's back up. Okay, let's restart that. Scratch. Sorry. Okay, I've already recorded this lesson once, but I hit enter when it was uploading and then it deleted. So that was a huge bummer. But let's see. We're given adjacent and hypotenuse. There we go. Adjacent hypotenuse. So we're going to use the inverse cosine to find the measure of angle G. Whew. All right, so inverse cosine of my adjacent side over my hypotenuse. And we're going to plug that in a calculator. You're going to hit, I'll do it with you on this one. You're going to hit second cosine, and that gives us the inverse. And then we wanted 16 over 25. That was adjacent over hypotenuse. And we get 50.2. So the measure of angle G is 50.2 degrees. That's good. It's an acute angle. We know that it's an acute angle. So now I'm going to erase this, and we are going to look at angle. Let's look at angle H. So looking at angle H, okay, now 16 is my opposite side, and 25 is still the hypotenuse. So now O and H, opposite and hypotenuse, means we're going to use the inverse sine function to find the measure of angle H. So inverse sine of opposite over hypotenuse. When you plug that on in your calculator, you're going to get 39.8 degrees, which makes sense because 50.2 plus 39.8 adds up to 90. So again, if you want to just check your work, we know the 90-degree angle they gave me, plus the measure of angle G, plus the measure of angle H should equal 180 degrees, and it does. And that's it for section 10.6. I am going to do the last two examples. You should pause it and try them on your own to see if you can get them right, but I'm going to do them pretty fast as well. So, Pythagorean theorem, leg squared plus leg squared equals hypotenuse squared. So plus 16 equals 36. Subtract 16 from both sides and we get 20. So y equals the square root of 20. And if you simplify that, you have a couple and a single. So it simplifies to 2 square root of 5. So there's our side length y. Now, let's look at E. So they gave me adjacent and hypotenuse, which is I'm going to use my inverse cosine function to calculate the measure of angle E. So adjacent over hypotenuse, and when I plug that in my calculator, I get 48.2 degrees for the measure of angle E. Last but not least, I'm going to erase this. Now let's look at angle D. Now 4 is the opposite side, and 6 is still the hypotenuse. So O over H is sine. So the measure of angle D equals inverse sine of opposite over hypotenuse. Remember, anytime you're trying to find an angle measure, you want to use your inverse trig function. So when I plug that in my calculator, I get 41.8 degrees. One other thing I want to remind you is that in your calculator, when you go to mode, it has to be in degree mode. So you don't want it in radian mode. You want to arrow over to degree and hit enter. And if your numbers are negative when you're doing these, then you're in the wrong mode. Alright, so we have solved this triangle because we found the missing side length y, the measure of angle E, and the measure of angle D. So now let's do the last one. Pythagorean theorem for the third side length. So I'm going to do it over here. Z squared equals leg squared. Nope. Ooh. Let's back up. The hypotenuse is 7. So hypotenuse squared equals leg squared plus leg squared. So 49 equals z squared plus 25. Subtract 25 from both sides and you get 24 equals z squared. Square root both sides. And then let's simplify this. That can break down to 6 times 4, which breaks down to 2 times 2, which breaks down to 3 times 2. So we broke those down further. So couples go out. So this couple goes out, and these singles are going to stay in. 3 and 2. So we're going to multiply 3 times 2 on the inside to get 6. So z equals 2 square root of 6. Now, let's use inverse trig functions to find the measure of angle h and the measure of angle g. Okay? Even though we found z, I don't like to use z. Let's just go off of the two that they gave me. So if I'm trying to find the measure of angle h, 5 is the opposite side and 7 is the hypotenuse. So the measure of angle h equals, well, O and h is sine. So inverse sine, since we're trying to find the measure of an angle, opposite over hypotenuse, 5 over 7. So the measure of angle h equals, We would plug that in our calculator and we would get 45.6 degrees. And last one, let's try to find the measure of angle G. So I'm going to erase this. The hypotenuse is still the hypotenuse, right? No matter what, that's always hypotenuse. So now if we look at the angle G, now 5 is the adjacent side and 7 is the hypotenuse, which means we're going to use the inverse. So measure of angle G, we're going to use the inverse cosine is adjacent over hypotenuse. So when you type that in your calculator, inverse cosine of 5 over 7, you get 44.4 degrees for the measure of angle G. And remember, these three angles should add up to 180. And they do. 90, and then these add up to 90. So that equals 180. And that's how you solve right triangles.